But today, I want to talk about the chemistry. That is the main thing. We have supplied specimen and some reagents that we are going to use for the practical of 2025 WAEC. But what I want to do today is, from the practical, we can fine-tune, we can predict the question, because the practical will lead us to where we can predict the question. Just like a student that's giving yam, they can predict that if we can cook the yam, and we can also use the yam to make porridge, and we can also use that particular yam to prepare pounded yam. So that is what the question can come out from the yam. They can also say fry the yam. So likewise, we can predict question from what we are giving from this particular specimen. Look at this one now. We are giving A. You all know that they normally represent A as acid and B as base. We are giving A is a solution of 0.219 mole per decimeter cube of hydrochloric acid, which is HCl. Then B is a solution of sodium iodine thiazocarbonate of unknown concentration. We don't know the concentration of this, but this one is known. A is known. Then we have to put A into a burette and titrate against 200 centimeter cube or 25 centimeter cube, depending on the one you use. So portion of B is using methyl orange is as a indicator. As indicator, carry out 2 more times to obtain a concordant of value. Now you have to carry, after you perform one, which is the rough one, you can also perform 2 times. So then you have to record the volume of your pipette and tabulate burette reading. Now they say you calculate the burette, because why must you calculate the volume of burette used? You know, we are asked to use 20 or 25 centimeter. So in marking that such particular WAEC, they will use it to cross-check what you have used. Now, what are we calculating here today? The average value of acid used, then the concentration of B in mole per decimeter cube. Then you also calculate the concentration of B in what gram per decimeter. So the concentration can be what measured in mole per decimeter or the gram per decimeter cube. So now the number of mole of this in this of solution B, you have to know that the mass of sodium ion in B. These are the things we are going to find. Now in this case, in here, this is what we do here. Now the rough work is 25. That is for the burette. Then from 0 we record this. Then the first reading is this, while the third reading is this. The second reading is this, and the third reading based on what we perform here. So your own school can be different from this what we have done. So now, how do we now calculate based on this question? Based on this particular question. So first of all, let me tell you one thing. If you look at this one, the rough, this is this, and the first titration, second titration, and third titration, you have to use the one that is close. That is what you use here. The one that is close. You can see 25 and what, and 24.80 and 25, 24.90 and 24.70. If you look at this one critically, we can see that we can use 24 point this and 24.90 and 24.70, where we neglect 25. You can see, because 25 has the outrageous difference, so automatically the difference must not be more than 0.05. So look at this one is bigger than, so automatically we use the first, second, and the third. So as the average titration. So meaning that the average volume of acid used is equal to this one, which is 24.80 plus 24.90 plus 24.90 and 24.70. So meaning you use 1, 2, 3, then you now divide it by 3 to get the volume of acid used, which is equal to, so add everything together. Let's add everything together. So we have 24 24.8 plus 24.9 plus 24.7. We have, so we have 74.4. So centimeter cube all over 3. So VA is equal to, then you divide it by 3. Dividing it by 3, we have 24.8 centimeter cube. So here the volume of the what? The acid use. This is the volume of acid use here. So the next question which they ask here, which I've already illustrated here, the next question is that you calculate the concentration in B. So we have recorded what this is the first question. There is no how they will not ask you this one. Let's call it A. So under A, under B, we can ask concentration of B in mole per decimeter cube. Now, having got this one, VA 24.80. So we need to calculate what we have done this one. Then we need to calculate the concentration of B in mole per decimeter cube. Now, then we need what formula. So what is the formula? The formula is CA VA all over CD, then VB equal to NA over NB. Meaning that the concentration of A, the volume of A, the concentration of B, the volume of B equal to the mole ratio of A and mole ratio of B. That is for the acid and base. Now, as a result of that, before you can do this one, we need to react acid to get the mole ratio. We need to react acid and base together. Now, let's write the equation of the reaction. So, the equation of the reaction, let me write this one so that I will not clean it to follow up. So, the volume of A equal to 24.80 centimeter cube. That is the volume, so that I will not forget this one. So now, let's clean this one to write the equation of the reaction. So we are to balance the equation by saying that the base is NaHCO3 then plus HCl then equal to, now this one reacts with this. We have sodium chloride plus what? Then plus water. Then because of this base is what? Is carbonate. So it will now release oxygen gas. Now let's see if the equation is balanced. So sodium here is 1, sodium here is 1, hydrogen here is 2, hydrogen here is 2, then carbon here is 1, carbon here is 1, then oxygen here is 3, oxygen here is 3, because 1 plus 2 will give you 3. Now in this case, what is the mole ratio? So we have ratio 1 to ratio 1, meaning that Na is 1, then Nb is also 1. Now you put it inside. Now before you now do that, let me clean this one. Once we have gotten the what? The mole ratio. Now let me now write the parameter. All the parameters given there. Let me write it. So Ca, which is the concentration of acid, as you can see here, is what? 0.219 mole per decimeter cube. Then Cb is questionable. That is what we are looking for. Then Va is the volume of acid U. The volume of acid U is what I've written here, which is equal to 24.80 centimeter cube. Then the volume of base used is the volume of bullet, which is equal to 25. We use 25 here, so we now have 25 centimeter cube. Now, I will understand this one, so we now put it into this equation to get the what? To look for the Cb. So now Ca, which is equal to 0.219, then times the volume of acid used is 24.80, then all over, then the concentration B, Cb is unknown, then times the volume of acid base used is 25, then equal to 1:1. Equal to 1:1. So the next thing we are going to do here is to continue our calculation. Now, in this case, we say 0.219 times 24.80 all over Cb times 25. Cross multiply 1/1. You cross it. So this one multiplied by this one multiplied by this. We have CB times 25 equal to 0.219 times 24.80, which can be given that CB equal to 0.219 times 24.80 divided by 25. Why? You divide both sides by what? You divide both sides by 25 to get CB. Now, we now have CB equal to, multiply this and this together using calculator. We can have 0.219 times 24.88, so equal to, so we have 0.219 times 24.8. We have 2. So we have 5.4312 divided by 25. So divided by 25, divided by 25. So we have the concentration of C, that is CB, equal to 0.217. 0.217 is the concentration, which is mole per decimeter cube. So now we have solved the second question, which means that for the part B, that is BI, which is the concentration of B in what? In mole per decimeter cube, which is equal to 0.217 mole per decimeter cube, which is the what? Then how do we now solve II, which is, they want it to go in gram per decimeter cube, in gram per decimeter cube. So that is what they want there. Now in this case, we need to, let me clean this one. So try to grab this one before I clean, or you play over and over. So now from here we can then calculate. Then you know that the what? How do we now calculate the second one, which is equal to, now we all know that what the concentration is equal to mass concentration over molar mass. So that's what we are looking for the mass concentration of this. The concentration is equal to mass concentration over molar mass. That is the formula. The concentration is equal to mass concentration over molar mass. Now, this is the mass concentration they are talking about. So making mass concentration, we can say N equal to, let me put this one as N, and this one is equal to M as mass concentration, and this is MM to be what? Then we now have M all over MM, meaning that this one is a molar mass. So now we now cross multiply to make M the subject of formula. So M will now be equal to N times M. So now in this case, how will you now solve this one? So for find the what? The molar. Let me see if there is what? The sodium and hydrogen. Let me see. Now, meaning that they will give you in that, but let me just predict it. Let me do it here. So sodium, hydrogen, thiazocarbonate. Let me put it here. But they will give you, let me tell you. So sodium is what? 23 grams per mole. Then we have what? Hydrogen is 1. Then we have what? We have carbon is 12. Then oxygen is 16. Now to now calculate all this, which means NaH0 and CO3 will give us open bracket. What is sodium? 23. We want to calculate the what? The molar, the molar mass. So hydrogen is 1 plus oxygen, carbon is 12 plus 12, then plus, because of this 3, we say 3 open bracket what? 12 for the carbon, 12. So we put 12 here. Close the bracket. Oh, this one is 16 oxygen, because it's O, it's oxygen, not 12. So we have 16 here. So now close the bracket. Now we now have open bracket 23 plus 1 plus 12, then plus, then 3 times 16. That is 48. 48. Now we now have 23 plus 1, which is, let's add this one, 13 plus 48. So add everything together to give us answer. So we have what? We have 23. We have 23 plus 13 plus 48. So which means then NaHCO3 will give us 84. 84 is our answer. So now let's now move back to this one. Then molar concentration will now be equal to, what is the concentration of the base that we got before? The concentration of base is this. We just say 0.217 times 84. So according to this formula, the concentration of the word base is this here. Then multiplied by this 84. So let's see what we are going to have here. Then times 0.217. So we have 18.228, which can be approximately to what? 18.23 gram per mole now. So now, okay, sorry, gram per decimeter cube. So this is the concentration of what in gram per decimeter cube. So they now ask you that the number of mole. Let me clean this one. So we are now to find the number of mole in what? Number of mole in, according to this question, the number of mole of this in one decimeter of the solution B. What is the number of mole of that? So now in this case, if you look at this one critically, you will know that NaHCO3. So when you now break it down, you dissociate it. You have Na plus what? The ion. So thiazocarbonate ion. So iodine thiazocarbonate ion. Then if you look at this, 1 mole of this is equal to 1 mole. 1 mole then plus another 1 mole of this. Both as 1 mole. This is 1 mole of this. Dissociate to this particular 1 mole. So automatically 1 mole of that will also give you 1 mole. Because there is no, this one, when this one dissociates, it's also dissociated to 1 mole, which is 1 mole of this. 1 mole of this will also give you 1 mole, because this is an ionic equation. Then the last one is the mass of sodium in B. The mass of sodium in B is what we want to calculate now. The mass of sodium in B, mass of sodium ion. It's mass of sodium ion that we want to calculate now. AHO3. So when you break it down, it will form Na ion plus HCO3 ion, which is what? 1 mole of this, also equivalent to 1 mole of this, and equivalent to what? Now, if you remember what we got here for the total mass after calculating the relative molecular mass, we get 84 gram per mole. So now, what is now the mass? The mass concentration of, the molar mass of this Na, which is sodium, is 23 grams per mole. So now, in this case, we are now to find the mass of sodium ion in B. Now, if you look at this one critically, we can say this one 18 grams that we get during that particular time. So we get 18 grams, 18 points. I think we get 18.8 grams. So then let's equate it to X. So now we now have 84 over 18.8, then equal to 23 over x. So we cross multiply, we say 84 over 18.8 cross multiply 23 over x. So this one we multiply by, we have 84x equal to 18.8 times 23. Then x will now give us 18.8 times 23 divided by 84. So using calculator to multiply. So I think this is 18.2, sorry. 18.2. Then 18.2 according to what we got last time. So we now have 18.2 times 23. We have equal to 418.6 all over 84. So our x equal to what? Divided by 84. So we have 4.98333, which is s can be equal to approximately to what? 983 gram per decimeter cube. So this is what we can get for the particular the mass of the sodium ion in the B, in this B is this one. So now they may even ask you for this. They can also ask you, because I'm just thinking, they can also ask you that the amount, or apart from what listed here, they can also ask you that amount of sodium in 25 centimeter cube. Let me clean this one. Let's assume they ask you that amount of NaHO3 in 1 deciliter of B. Now, if you recall from our, so we get our what? Concentration of B. Concentration of B to be 0.217 then mole per dmq. That is what we get. Now, what we are saying is, if this one we dissolve in 1 decimeter, so what of if it is 25 centimeter? So we just say that if 0.217 is dissolved in 1000 centimeter cube. So now x of this, which you don't know, we want to know this, so we be what? 25 centimeter cube. So that we now have 0.217 over x, then cross multiply 1000 over 25. So this one multiplied by this one multiplied by this. So we now have 1000 x equal to 0.217 times 25. So our s, by divide both sides by 1000, we divide both sides by 1000, so that our x will now be equal to 217 times 25 over 1000, which will give us, let's multiply using calculator here. So now we have 0.217 times 25 will give us 5.425 divided by 1000. So dividing this one by 1000, x will be equal to, divided by 1000, so s will give us 0.00545, which x can be approximately equal to 0.0054, then what? Mole per decimeter cube. So this is the what? So this is what. And so now they can even ask you that the number of hydrogen in 1 decimeter cube. Let me try to fabricate this one. The number, let me clean this one. You can also ask the question like this. So they can also ask that number of hydrogen ion in 1.00 decimeter cube of A, of that A. Now if you look at this one, how will you solve this particular question? Now dissociate HCl, which is hydrogen. We are talking about hydrogen. So we dissociate hydrochloric acid, HCl, into hydrogen ion plus what? Chlorine ion. So we have 1 mole of here, then 1 mole and 1 mole of here. Now, in this case, you know Avogadro law that one atom or particle is 6.2 times 10 raised to the power 23. So which means one mole is equal to 6.02 times 20. Times 10 raised to the power 23. That is for one mole. Now, if you now go to the mole, how many mole of hydrogen? A is what? 0.217. No, 0.219 here. So of mole. So meaning that 0.219 mole here. So will give us x. It's x. Let's assume it's x. So we now have 1 all over 0.219 mathematically, then cross multiply 6.02 times 10 raised to the power 23 over x. So this one multiplied by this one multiplied by this. So meaning that x is equal to 0.219 times 6.02 times 10 raised to the power 23. So x will give us 0.219 times 6.02 times 10 raised to the power 23. So we have 1.318 times 10 raised to the power 23. So that is the number of what? The number of ion, the number of hydrogen ion in one decimeter cube of A. That is the number of hydrogen ion here. So this is the final answer for the digital question. So I wish you the best of luck. So they cannot ask more than what I just asked. The only thing they can ask is the percentage of impurity, and the salt is pure. So you can see there's no element of it adding X to this, or they mix some two salts together that you find the percentage impurity of the salt. So that is the only thing that they can ask, and the salt you use is pure. So thank you. I wish you this best success. Okay, welcome back. So we just concluded a part A of that particular chemistry practical, but this is the second part, which is called salt analysis. So now look at this one. Now we are asked to prepare C, which is a mixture of an organic and inorganic, meaning that C contains mixture of organic and inorganic compound. So substance. Carry out the following exercise on C. What they ask you to find on C. What are the things that you are asked to find on C? So record your observation. Anything you see, just record. Then and identify any gas involved. The gas that involved, we look at it. Then state the conclusion you drawn from the result of each test. Each test you perform. Meaning that you will have many, or we will have, or you will have many tests. So you now record all the tests. Then the first test you are asked to do, the first thing you are asked to do, put off C into a beaker. You put that C, this particular, into a beaker and add 10 centimeter cube of distilled water. That is, you add water 10 centimeter. You measure 10 centimeter cube and shake thoroughly. You shake it thoroughly. Then test the results. Test the resulting solution with lithium paper, whether it is acidic or alkaline, or it is neutral. It can also be neutral. So then you now divide the solution here above into 4 portions. Divide it this test to A, B, C, D. So you then to the first portion you add aqueous NOH, that is sodium hydroxide, in drop. After you drop, then in excess you now add in excess. Then for the second portion, you add aqueous ammonia in drop, or in excess you had it. Then for the third portion, you add barium chloride solution, and then distill after you had barium, you now add what? HCl, which is hydrochloric acid, then in excess after that one. To the last portion, which is the fourth portion, we have Ferlin solution. We have 2 Ferlin solution, A and B. And after you add it, you now heat it. So what do you observe? This one is very simple. It's the most simplest part. Whatever you see is what you record. And you must are familiar with all these elements and ion, the character, the color. That's all. Once you know all this, you are good to go. So let's perform the experiment. Okay, welcome back to the second part of it. So this is the result of what we got when I performed the experiment. This is the result. I'm still going to perform it in reality, but this is the result of what I got. So now, we talk about C. C is organic and inorganic substance added to water. So what happens is this: C is soluble in water, what we observe, to give a blue solution. Now, after this C contains mix of soluble salt. That's what we observe, because it is soluble. Definitely the salt is soluble. That is what we observe. This one you can make everything. So even if you don't know this one, nobody in the world that will not know this one, because it's what you see. Then you now talk about inference, because number one, you had it, the color, you see the color. Is it red? Is this blue? Is this yellow? You see what happened. Then C contains a mixture of what? Soluble salt. Definitely the salt here, organic salt you see here, and inorganic soluble. Then the other one we saw, solution C, that is plus litmus paper. That solution we prepare now, we put litmus paper just to know whether that solution is neutral or is acidic or is also basic. So that is what the essence of this. No effect, meaning that the solution is neither acidic nor base. So then you test it with litmus paper. So what we now just think of, it contains copper ion, is confirmed. So now the first portion, I told you that we have four portions. So the first portion, we are asked to add sodium hydroxide in drop. Before we put drop, then you now put in SS. So after that, what we observe is a blue precipitate is obtained. The PPT is precipitate. That is the short form of precipitate. PPT is obtained. So we now see the precipitate. Then an SS insoluble PPT, which is what with precipitation, is confirmed in SS. Now that is not dissolved as well. So now in this case, we also suspect this one. This one is present. That is copper ion is present. Now we now further move to what? To the portion B, which is the second portion. Now in second portion, now we had, instead of NaOH, which is sodium hydroxide, we added the ammonia in drop and in SS. So what we observe is also blue. That blue is confirmed in drop and more in deep blue. When you now put more in SS, is deep. The color change to deep blue is confirmed in SS. So now we see based on this thing. This is what we are suspecting here. So now after that one, the next thing is that to the third portion, we discard this, then to the what? To the third portion. The first thing we do, we had barium chloride. Then after that, we now have HCl, which is hydrochloric acid in SS. Now we observe white precipitate confirmed. The white precipitate confirmed. Then the precipitate is insoluble in SS. It is not soluble in SS of hydrochloric acid. It's not soluble, whether it's drop or SS. So that makes us to suspect all these gas: SO3, SO4, and CO3. Now we are going somewhere. Now after this one, then we now, because these are the characteristics of the ion that can be under this particular observation. Now the fourth one, which is the final one, which is, we now take that one again, the last test tube. What do? We had Ferlin solution. We have two Ferlin solution, A and B. We added. After we added, we now heat. Then what do we observe? No chemical reaction on Ferlin solution. We don't observe any chemical reaction. So after that one, then we now have a brick red precipitate is formed after heating. After we now heat it. So we observe brick red precipitate, then which confirm what? Glucose, which is glucose. Reducing agent, reducing glucose is present. That is that one. You all know that when you put Ferlin solution into any glucose, we change to what? We change to this color. So which confirm there is a glucose. Definitely, they talk about the gas release from that particular thing. Let me tell you now, you all know the gas release should be CO2, because the gas turn milky after passing what? After passing the gas milky, showing that there is a copper will show that what? Which means copper plus this, copper thiocarbonate. then because of the presence of glucose, this is the formula of glucose that release that gas. See, let me get this is formula of glucose, 6H O6. So give this one. So here is what I can explain. Whatever you see, just record it. So let's start the practical. Now, take out. Now, we are asked to provide C, which is a mixture of organic and inorganic substance. This is C. This is a 10 centimeter cube of C, which I've prepared. I've mixed it together. They have added water. This is C. Now, let's now go to what we are asked to do with that C. Now, the first thing we are asked to do, they say put all of C into a beaker and add 10 centimeter cube of distilled water and shake thoroughly. So I've shake it. Now the second one, if you go back to what I just explained from the board, test the resulting solution with litmus paper. They are not specified. This will make you to test for both blue and red litmus paper. So now this is red litmus paper to check. So this one will test if there is acid. Let's see. See. Do you observe anything? No. Meaning that it has no action in what? There's no reaction with it, with red litmus paper. So let's now test the what? The blue litmus paper. Do you observe anything? No chemical reaction. So that confirms what we just go back to the board. We say there's no any visible reaction with that. So the second thing we have to do, after we've tested with litmus paper, we have to divide the solution into 4 portions. So it's what I'm doing now, into 4 portions. This is the first portion. This is the first portion. We have to divide it into 4 portions. This is the second portion. The second portion, and this is what? This is the third portion, and this is the last portion. So this is broken one, so I need to bring another one. It's a broken one, so wasted. So let me just try to put it in another one. Let me try to. So that one has broken. Now, so then look at this one. So we have done the one that we have to do. Then the next one, second portion. If you check what I just explained on the board, now let's confirm it. Then the second one say, okay, we have said the first portion is soluble in water. So you can see soluble there. The second portion say no effect on the litmus paper. The third one, the first one that we are added. So the first one, we had sodium hydroxide in drop, then in excess. So let's take this one as the first one. Sodium hydroxide in drop and excess. Let's look for the sodium hydroxide. This is the sodium hydroxide, as you can see. NaOH, the sodium hydroxide in drop. We have to do in drop. Let's do in drop. This is in drop. So now in excess, you can see in excess. If you look at this one, this is blue, change turn to blue. You can see it turn to blue, but you can see particle there. If you look at the particle, which will be insoluble in drop and excess. So we have done that one for the first portion. So blue color but insoluble, as you can see again. You know the color, you can, let me compare, you can see to show that it has turned to blue, and this one you can see some particle, so which means insoluble in both in drop and excess. Now I'm following the question. The second question say to the second portion add aqueous ammonia in drop and excess. So this is second portion now. Now look for the ammonia. Ammonia, this is the ammonia. As you can see, this is the ammonia. We are asked to do it in drop, and I want you to compare what we are doing here with what I just that I've illustrated, whether it is true or not. In drop, this is in drop. Now in excess, let's see what will happen in excess. You can see change of color again to blue. Let me add more in because it's excess. You can see what happened to the second portion in drop and in excess. So what happened? You can see it has turned to whatever you see is what you record. Is that taken? So now you can see that it is soluble. There is no particle there. And if you check it, it is what? It is soluble. You can see no particle. If you compare the first and second, no particle here. So definitely, so it's whatever you see. It's you that will do it. Whatever you see. Now let's look at the third one. The third one, we are asked to add barium chloride, then and as well the hydrochloric acid. That is what we are doing. Now this is the third one. Now barium chloride. Let's look for the barium chloride. The first thing you had barium chloride. The barium chloride is this. This is barium chloride. Let me show you the barium chloride in drop. This is in drop. You can see. Then let's now look at it in excess. You can see. Now, if you look at this one in excess, now look at it. There is a particle which is called white precipitate. You can see the precipitate there. So we can see that white precipitate occur. So now, then let's now add hydrochloric acid after the barium chloride, because we have to add hydrochloric acid. You can see also white precipitate occur there. So now the final one is this. The last one we are asked to add for the fourth portion. We have to add. That is what you'll be looking at in your question. Just follow the instruction. Whatever you have to do is what you do. So assume that you don't know the answer. So now we have to add the acetylphenylene solution A and B. A first and B. You can see. Now let's look for the phenylene solution. Okay, now this is our phenylene solution here. So A and B. This is A. Phenylene solution A. Now A and B we have to add. So this is A. You can also see precipitate there. So now white precipitate. So now add the what? B. Correct. You can see. What do you observe? Blue. You can see. You observe it now. It is not magic. You can perform it anyway. Even what you see in your exam, you can see blue. Now after that, after you now had A and B, you are asked to heat. Let's eat now. It's time for us to eat it. You can see. I'm heating it now. For those that are going for lab tech, testing of what, this is what they are doing. To test glucose in your body like this. You take it. So let's see what will happen as we are eating. Let's see what will happen. Although it's much for the heat to. You can see that it has changed to brick red, as I said. Let me tell you, don't let anyone, be the school or anyone, render you useless. That is what they are doing in hospital. Test of anything. The reagent they use the reagent that reacts with that thing will give you a result of. So you can see. From blue to what? From blue to big red, which you can record. Whatever you see, just record it. So now this is the result of this. But mind you, physics is coming, economics is coming, and mathematics. Just stay tuned in this particular channel. Thank you.